The denominator of a higher index radical. Okay, this right here, that's called the index or the root. So if you see that word index, it just means this number right there. So you have the cube root of 25y and the cube root of 4x squared. Now when I had a square root times a square root cancels each other out. If I have a cube root, I can't just multiply times the cube root because all I've done is squared it. It won't cancel out. There are two ways to go about this. Okay, I can look at this. Okay, so see how I have a perfect square? This is the same thing as the cube root of 2 squared x squared. To make these thirds, I only need to multiply one more in. Correct? I want 2 to the third, x to the third. So I can multiply this by the cube root of 2x. And that will give me the cube root of 2 to the third, x to the third. And this would be the cube root of 50xy. And now cube roots of thirds will go away. So my denominator would be 2x because these cubes cancel with the root. And then I need to look at my numerator and see if there are any cubes in there, which there aren't because 25 is 5 times 5 and times 2 is 50, so there's no perfect cubes in there. So that's 50xy. Now, the other way to go about it requires less thought. Ends up being more reducing at the end, but less thought. Okay? If I have cubes, if I square a cube, or if I square a square and it cancels out, I would cube a cube root to cancel it out. So I have one of them, so I can multiply by 2 more. So now I have 3. Does that make sense? So I have 1, 2, 3. So if a square root times a square root cancels the square root out, if you do 3 cube roots together, they'll cancel each other out.
Is there a 2 or 3 on the end?
That's supposed to be a 2. Yeah. But you see what I mean? So I have 1, 2, 3, so they cancel that way, which means I would then have to multiply the numerator by 2 of them. And so what I end up with is 400. X to the 4th y. And now 400 I would have to take out. So I end up with it's, 50, 25, and that's 5 times 5, and my set of 3's that come out is a 2, right? So that would be a 2. And then I have 4 x's, so I can bring one of those out, and what's left inside was 50, that x that's left over, and that y. And then my 2 will cancel to my 4, and this x will cancel one of those. So I end up with the 50xy over 2x. So same answer. It's just that here I figured out what I needed to do to cube what was inside and go from there. So I'm multiplying by less. Whereas here I just decided to go ahead and cancel the cube by cubing it. So I didn't have to think of what do I have to do to make this a cube, but then I had more reducing at the end. Don't worry, I will do another one. Okay. When you have a fraction under a radical, you can split it. Okay. Using that first method, 49 is 7 squared. Okay. So if I want to make this a cube, I'm going to multiply by another 7 and another x, because that would make this 7 cubed, x cubed. Whoa, that's not supposed to be a 3. That's a 9. I don't know why I did that, sorry. So then this is the cube root of 9. Sorry, not 9. The cube root of 9 times 7x, so 63x, over the cube root of 7 to the third x to the third, right? Because x squared, or 7 squared times 7 is 7 to the third. So I get the cube root of 63x over 7x. Does anybody want to see the other method again? Yeah, okay. Here, actually, I'm going to try to make this a little smaller so I have more room. There. Okay, so same general idea. I have to split it. And if I don't see the squares, to get rid of a cube, I have to cube it. So I multiply by 2 of them, since I have 1. So this gives me the cube root. Oh no, it's supposed to be squared. Thank you. I'll fix that in just 1 second. 49 times 9 is 441. Sorry, that's a squared. So 49 times 9 is 441, and this is 49x squared. Okay. So then I take my 441. Oh, sorry, there's 2 of them. Duh. That's too small. I stopped writing. Okay, so 49 times 49 times 9. That's ugly. And then that's over 49x squared. So 21609, that will divide by 3. Or I know it'll divide by 49 because I multiply the 49 into it, right? It's actually 49 times 49 times 9, right? Well, because that's what I multiplied together, 49, 49, and 9. This method, like I said, it's a lot more work, less thought. So I can pull out a 7, and I can pull out one of the x's, and I'm left with 7 times 9, so 63x over 49x squared. 49 and 7 will cancel. And one of the x's will cancel, so I have 7x. This takes less work. This takes less thought in the initial part. This method is good if you don't see a square in there. Like if you can't figure out what to multiply by to make it a cube, then this will work because you can just cube it. This method is more efficient. So one more. 2x to the 11th. Okay. To cube a 2, I need 2 more 2's. I have an exponent of 11. I need an exponent that will divide by 3. If I add one more x to this, I'd have 12, right? And 12 divides by 3. So what I end up with is the cube root of 100, right? Because 4 times 25 is 100. U squared x over the cube root of 2 to the 3rd x to the 12th. Uh, 100 is not going to have a perfect cube in it because I have 2 squared and 25. There's no extra 2 or anything like that. So that's going to stay the same. And then I have 2, and I do 12 divided by 3, so that's x to the 4th.